Good afternoon, good morning, good evening, wherever you're joining us from. Welcome to my talk titled Focusing on the Recovery Aspects of Cyber Resilience. So for those who know, I joined Pearson PLC, the world's leading organization, just at the beginning of the year. Prior to then, I worked in nation critical systems for several years. So designing, building, and occasionally also running highly available defense systems for cyber security centers. So that's my specialty. And the reason I say that is when you're building mission critical, nation critical systems, there are a number of things that come to mind is to build those systems so that they're very robust, to ensure that the systems you build also can be future-proof and withstand so many requirements, and also being able to even auto-remediate if there is an issue. But one of the things that is common from my experience, and this is a universal reality, is that things fail. So, and because things fail, move to the next slide, please. So this Murphy's Law couldn't be any real than if you are working from experiential reality that if anything can go wrong, it will. And that gives us another dimension to think about things. And I've captured this to reflect cyber physical social systems. So to bring to bear that universal reality, I will take you through 3 use cases or 3 scenarios to illustrate what Murphy's Law in terms of if anything can go wrong, it will. So on Friday, the 22nd of November last year, Elon put up a demonstration of the Tesla Cybertruck. Anyone who watched it would attest to this. So it was a public demonstration to fans, to shareholders, to stakeholders involved. And as part of the demonstration to showcase how strong and how resistant the Cybertruck is, the part of the demonstration was to give a metal ball to the head of design of Tesla, Franz van Hansen, to throw on the left side of the Cybertruck, and he smashed the left side. And Elon joked and said, okay, try on the rear side. He did, and that rear glass also smashed. The point here and the lessons to be learned here is that if anything can go wrong, even though we've designed it with all of the good intentions, with all of the advanced technologies, and tested it in a test lab, in production, in a model, but things still break and things can go wrong. And that's no criticism to Cybertruck. After all, Elon, they landed astronauts 2 weeks ago to the International Space Station. So that's not a small feat. That's quite tremendous. But the takeaway here is if things will go wrong, they will definitely do. And even whilst we design to avoid those things, things still do fail. And that's physical systems. So the next slide, please. So if you then reflect on our cyber world, our cyber systems, so cyber systems fail for a number of numerous reasons. Inadvertent, somebody could make a mistake, fatal mistake, and it will result to cyber systems failing. Cyber systems can also fail due to physical intrusion and physical failures that will then exacerbate and result into the cyber systems failing. They could also fail by attacks or breaches. And if you guys remember, for some of you that would do, the heartbleed is a typical example we're relying on our crypto systems, we're relying on our SSL secure circuit layer, but it was the open SSL exploit that Heartbleed exploited a known crypto system suite of software that we use to protect our cyber systems to then launch that exploit. So things will fail, exploits will come up. Another one that is also quite pertinent is also the meltdown and the Spectre exploits or vulnerabilities on modern processors. So modern processors can be, there could be software programs that could exploit failure in modern processors to steal data. And that is exploitation on mainstream cyber systems, things that were tested and relied upon for years and centuries, and we are so confident because they're mainstream and we believe they would not be exploited or fail. So these things happen. Again, what we don't even know is the emerging aspects of the new world, what things like quantum computing could bring to bear, where you could compute things in parallel and parallelize things and work in qubits instead of bits. And then it means that our crypto systems are relying on how difficult it is and how long it will take you to crack those codes will become very susceptible in the new world. Therefore, we need to plan for what happens when it does happen, not if it will happen, is as a matter of when. The next slide, please. But then you say, Cyril, that's about physical and cyber systems. What about the social systems? And that's why we call this the Great Swan. The Great Swan are things that we believe never will happen, will never happen. And we're living that world now. Say, you would say, oh, several years ago, the Twin Tower attack, the Americans never saw that, the US guys never saw that, it happened. But we're living in a COVID-19 world that impacts, is a pandemic that impacts the global. So it's not about sectorial, it's not about geography now, it's about everybody and anyone is now impacted. And this is the sort of world we live, and hence why Murphy's Law that says if things can go wrong, it will definitely go wrong. So these three takes us through the various spaces, so to speak, the physical, the cyber, and the social space. And that could be something that we take away, knowing that the reliance we have on those systems, the reliance we have on people, and the reliance we have on processes will someday fail. And then what do we do? And that is the crux of this discussion. Next slide, please. So as you look at cyber resilience, so cyber resilience encompasses 4 different aspects. So the preparation, so this is about preparing, planning, even doing forecasting, modeling, predicting that things will happen. And therefore you then build in those constructs within the withstanding aspect, which is how do you absorb those? How do you continue in the face of an attack? What do you do? So we're building structures and advances in that area. Things like auto-remediation, things like in cloud computing, you can leverage regional technologies and load balancing things and clustering and various complexity, what we call fault-tolerant and resistant technologies and processes. But things still fail. So that's why with resilience, you then look about the recovery. If it does fail, what do we do to recover? And then adapting is about post-incident recovery. So you've catered for the incident, what do you do? How do you adapt your processes and procedures and people and thinking and the new ways of working to come to full cyber resilience? What we found out in our research is that the extant literature has so much depth in terms of preparing and withstanding, and very little in terms of the recovery. Yes, the National Cyber Security Framework, the NIST Cyber Security Framework, will tell you about recovery, but it's a word, and it will tell you this is recovery is about to recover when there is incident. None of the standards we looked at and none of the extant literature we looked at has gone in depth into telling people or organizations what you need to do in a methodological approach that allow you to do that in your office but also to adapt that processes and allow you to implement that. And that's what this presentation is about. Next slide, please. So what we have formulated and created is an operational framework, say a cyber recovery operational framework. It's an 8-pillar, or what you call 8 different dimensions. I use the word pillars or categories or areas. And on the right-hand side, it starts with identify, control, map, plan, play, test, measure, improve. And you think, oh yes, it's like the PD act, plan, do, act, and plan. Yes, it has a relationship to existing approaches, but also it has to be novel in a sense that it has gone into providing us a framework in which we can then operate, in which we then can build our processes and procedure and technology and people to then provide operational framework. So this is just the overarching aspect of it. And there are about 41 sub domains on which these 8 pillars build on. Next slide, please. So it's these 41 sub-processes underneath the 8 pillars is what our full version is. This is a presentation, so I won't bore you by explaining all of those 8 pillars here, because you will lose the explanation and it might not make sense to you. So what we've done is that we've chunked it into a way that you can take away this model, understand it as we explain. So the next slide will walk you through 4 of those each pillars so that we explain it in much depth. Next slide, please. So this is the overarching 8 pillars. So you have to identify and to prioritize your resource. And the second pillar is the control and the capabilities for your cyber recovery. And the third one is the dependency mapping. So you map the dependency. I will explain that in much depth in the next slide. And the fourth one there is the recovery planning. So you have to do some planning. And the fifth is the recovery playbook. The sixth is about measures and metrics. So you have to measure things against what to know whether recovery was complete, partial, or failed. And then the seventh there is testing. You have to test those recovery capabilities. Of course, there will be continuous improvement. Next slide, please. So the first 4, so I'll walk you through that left to right. So in the identify and prioritize results, what you want to do there is to be able to identify your critical technical and non-technical aspects. So this includes your people, the processes, the procedures, the technologies that would allow you to recover if there is an incident. So that is very important. But also what you then need to identify equally are key stakeholders and their responsibilities. So you need the decision making, you need who would authorize you, but also you need the technical people to do that. But you also need the other stakeholders, and this could also be stakeholders also in the reliance scope. So if you're working in CNI, which is the critical national infrastructure, you also want to have a liaison with the NCSC, for example, if you're in the UK, which is the National Cybersecurity Agency. And if you're in the US, you want to also have links and liaison to DHS, which is the Department for Homeland Security. And depending on where you are, so in our paper, all of these different stakeholders are listed there. But no organization, especially now with COVID-19, people are losing jobs. I looked at the news before this conference and I saw that we had over 60,000 people who are going to lose their job in the next month or so as a result of COVID-19. Therefore, no single organization has got a blank check. No single organization is not constrained. So we are constrained either resource capacity or people capacity. Therefore, we would not be able to cover or recover everything. Therefore, you need to prioritize your assets So which assets are critical, which one are less critical, which one are medium critical, and which one can you live without? And that gives you the right, aperture of tolerance. What do you do? And you can do that by your business impact assessment, organizational value of that asset, and the importance. The second pillar is, what are then the control and capabilities you have as an organization for recovery? It may well mean that you're starting from a clean slate, in which case you haven't got any. That's fine, it's not bad. What it means is that you've identified that there are no existing controls and capabilities within that organization for your recovery mission. And then you document that, which means as you plan ahead over the roadmap, you can then say, okay, there is a gap there, and we need to start to then implement those, and we need to start to have those processes and procedures and people aspects there. The other bit, which is also important, all of them are important, but this is very, very important, is the dependency mapping. And we're not talking about project dependencies here. We are talking about understanding that there are systems that are critical to you, as you saw in the RCI3, which is prioritizing asset. Those assets that are your crown jewels, so to speak, might be a subsystem in another system. Therefore, when you do your prioritization, you need to then have the dependency to say, our crown jewel is actually a subsystem to this other system. Therefore, you cannot remedy this system without remedying the actual super system in which your crown jewel is a subsystem of. The other bit of dependency mapping is, how do you then do recovery? What is the sequence of doing the recovery? I'll give you one example before I move on. Is if you are an administrator and you want to, say you've been attacked and you felt, okay, you guys needed to auto remediate something, and you needed to do some patches, and you need to then restart the system so that the new patches kick in. If you are not mindful and you haven't got out-of-band access, you haven't got backdoor access to that system, and you reload and the system hangs, it will drop you at the kernel. At the kernel, you will not be able to use the conventional approaches to log in, like your SSH or RDP or whatever. You've actually exacerbated the situation and caused it more fatal. Therefore, when you're drawing the sequence mapping, you also drawing the sequence map to the process handoff and also to technology handoffs. And on this particular other slide here is your recovery planning. So once you've done the dependency mapping, you then need to look at the recovery plan. How do you plan recovery? When do you then plan and schedule testing? That would go into your plan. So what are the recovery processes and procedures? I call them artifacts or collaterals that the organization need to set up. Who would then become your contact for external communications? You need to identify that, including how you communicate those bridges out. So you would have to have communication policies and what we call protocols. Who should be, and also based on certain principle, for example, they need to know principle. And then who do you share those insights with? Where is the community of sharing? Where is the trusted community? I remember yesterday, one of our presenters talked about the TPL and the traffic light protocol, and amber and red and green and white sharing. These are the places to understand those and know who your sharing partners are. And also, what are the recovery contingency measures? So if everything failed, what are the contingency measures? And lastly, but very important, is the decision making. So you want to be able to also identify within your planning who are your decision makers and what decisions you are seeking from them in order to get this recovery planning complete. Next slide, please. So the remaining 4 pillars. So once you've done your planning, you need to play it. You need to play the playbook. So the playbook would include things like the war gaming. So these days, everything is about game theory. So we use game theory in some of our modeling, and we use affinity diagram, and also we used system diagram. So there are lots of methodologies you find in our paper, how we've come into this, and of course also experiential knowledge. So you then do the war gaming and the various scenarios, the what if and that in your playbook, and also then derive out the compromise path, but also derive out the impact each one would have. And then that then predicates and then also tell you what sequences you would have in terms of the playbook. But also the recovery processes, what is the resultant recovery process. So when you start, they're all potential, but then as soon as you start to identify using your cyber war game, the various likelihoods and then the various impact, then you then start to prioritize your recovery process. And that's what that is trying to say to you. And also what you should do, including the fixes, what fixes you should employ, when do you test, and what would become a recovery success criteria. That then leads you into the metrics. So you have to have your measures. How would I measure recovery? What are the service level agreements? What are the operational level agreement? What are the KPIs? You'll notice quite immediately that we have KPIs. We also have metrics indicators. The same principle of you will not be able to solve the whole world. Therefore, you need to prioritize which ones are critical assets and prioritize which ones are critical processes, whether it's your intellectual property you want to protect and recover from those quite quickly. The same way you have to say, okay, here are the key performance indicators. There might be 20% or 10%. If we meet it, we would believe that the recovery mission is successful. However, these are nice to have. These are based endeavors, and that's what forms the recovery performance. And an uplift of that is your KPI, the key ones that you want to measure against. And the penultimate pillar is your testing. You have to then test your playbook against the metric to look at efficiencies. Therefore, you want to test it by interviewing your recovery stakeholders and external, but you also want to do threat modeling. So you do some TI exercises or CTI exercises to threat model your playbook, and then against some known threat intelligence. It could also be a tabletop exercise, your TTX, and then you can automate this. So all of this framework can be automated in Agile or DevSecOps so that each of these can be codified. The last bit there is if you work in some mission critical areas like CNI and you have the threat intel, you could actually have a focused threat intel and then have the right team to exercise that like the red and blue team exercise. In the UK, we have schemes like STAR, C-Best, and G-Best that are tailored. So you could say, okay, we are going to be, from our war gaming scenarios, we found that the major threats here would be a ransomware attack, because if he manages to encrypt our database, and because the way we engineered it and architected it, our database is one single place. Therefore, if he encrypted it and the policy says we should not pay ransom to then, with the bad guys, that would be our major threat. What you then want to do is to have a C-based or G-based or a tailored red and blue exercise over a specific CTI against the target. So let's make that quite actionable. So you would then have to threat intel a ransomware against a CNI control and how that would impact. And if you did compromise it, how would you recover? If you didn't recover, what would it be that you can lose? And what would the impact would be like? If that system failed, would it fail open? Would it fail closed? What are the apertures of risk? And that's where you can do some tailor and specific testing. The final bit then is whatever you've done then goes into your continuous improvement. So using best practices, making sure you minimize the recovery gap, also having those playbooks updated regularly. And another important base, again, as all of them are important, but critical equally, is that from Fiona, in reference to Fiona's discussion early today, she mentioned that people should no longer be the weakest link. And we've always used that phrase as people are the weakest link, but it shouldn't be that way. We should train our people, upskill them to be able to do the work and do the work well. But there's another sub-control there is, once we know that you train your people and equip them, but they may not have the specialist skill as when you need it for a particular goal, that's why we have a call-out contract. So you can also have a call-out contract to a specialized organization. All they do is cyber threat recovery, so that if you hit those significant cyber incident, whilst your people are helping you do that, you could also call out to those agencies and those specialist organizations to help. Next slide, please. So then you said, Cyril, you guys are, the model is good, is complete, but is onerous, is too big. How can any organization do that? We recognize that, hence why we have the lean version. So this is our lean version. So the lean version has compressed the 8 different pillars comprising the 41 sub-controls into 8 collaterals or steps or pillars that you need to do. So the lean version then steps through, rather than go through the whole full version, the lean version is only 8 processes that you need to be mindful of. So all it says is you need to, for you to have some level of cyber recovery capability in the organization, you need to do a discovery. So you need to find out what exists first, and from there build up. And when you do find out that this is what exists, and then you map it as in draw up your dependency map, that effectively gives you your gap analysis to say, okay, we have nothing and we understand the dependencies. Here is the gap. Therefore, we can then tranche the deployment into your roadmap. The third one there is then to look at the recovery plan based on what you know, which is the discovery that nothing exists, to the dependency in terms of system, people, and processes, and the cyber recovery plan with your playbook. Then you have a recovery report. That report will effectively highlight the various things you are missing in that journey of the cyber recovery journey. If you had any capabilities identified in your discovery exercise and processes and people, you then want to test it and exercise it against the playbook, and then drop a roadmap of work, which is the final stage in a lean version or our limited version. So that way you then have a roadmap of work that structures how your capability upskilling both people, process, and technology would evolve over time, and that's what you have in the model. Next, please. Next slide, please. So in conclusion, for an organization to have an efficient and effective cyber resilience, they have to cater for recovery. They have to plan that someday the controls that could withstand, could absorb, could adapt, will fail, and therefore they have to have recovery in place. So although resilience touches on the 4 areas of prepare, withstand or absorb, recover, and adapt, what we found out is withstanding alone in terms of being very robust to contain the attack is only a matter of time. Just like we saw with the cyber truck, just like we saw with the various cyber incidents that happened. Hence why data breach is on the rise, even in spite of advances in technology, in spite of advances in the cyber controls that we have and our practices, yet data breaches is still on the rise, and hence why recovery should equally be taken importantly. Again, a note of caution and one takeaway is that cyber recovery is not a product, it's not a tool, it's a journey. It encompasses both the people, the process, technology, and also what we regard as the decision-making aspect of the people. So for that to be successful, organizations need to be mindful that it's a journey, and it will take some time to get there, and hence why we advocate on drawing up a clear roadmap and that are measurable for you to achieve that journey. But, and also equally mindful that it's not a switch that you flip up and down. It does need capacity and resource and commitment from senior leadership to achieve that. Again, our framework and how you apply this should be adaptive. So as new TTPs, the tactics, techniques, and procedures evolve, our framework evolve. Again, that's why our framework is done with a full version and also with a lean approach that allow you to build capabilities with apertures that you can move around, and based on your roadmap, still achieve the end game when you get there. Whatever you put into cyber recovery needs to be controls and processes and playbook and runbook must be tested and exercised. We advocate for regular automation, i.e. automate those so that these processes can be tested in real time, and we evangelize for continuous assessment and continuous testing, continuous evaluation. Again, that chimes into the new concept of your set DevOps and your CI/CD, CM type model, where you can automate these and test these over time and have baked-in security into your thing, but also baked-in recovery procedures into your processes. Staff needs to be trained, they need to be upskilled, at least so that they can provide that first line of defense in terms of first line of recovery before you enlist the specialist recovery organizations. And of course, it's a journey of training people. Lifelong learning is also what we advocate. Therefore, training people is only going to be an asset and benefit for any organization. Thank you, and with that, I would like to take questions. Next slide.
Thank you, Cyril. Fascinating as always. We have a few questions for you. The first one is, during the identify and prioritize resources first phase, would you also consider the maturity of the cyber perspective of the resources in order to develop the training?
Absolutely. So one of the things we do to implement this is you will do a discovery exercise in terms of the capability, cybersecurity capability of that organization. You also want to also, as part of the discovery exercise, to understand the risk tolerance and the risk aperture of that organization. So if you imagine some banks, I'll give that as an example, issue a credit card, and they know that there will be theft of credit card, they know that people can clone it, but there is a risk tolerance there that if it does get cloned and it does get stolen and the money goes, they have a fallback in terms of whether they do cyber insurance as part of those, or the profit they get by issuing those cards surpasses the risk in terms of how much loss. So it's important to also assess the cybersecurity capability of that organization as part of cyber recovery.
Great. One question from me. There is usually the common belief in organizations that by testing you will break things. So what would you tell them?
I would, the testing we would advocate is we do testing in model. So that's why in our testing we had tabletop exercises. There are things you can find out in tabletop exercises. There are things you find out during wargaming, which are all hypothetical. There are things you derive from scenarios, what if. But if you are genuinely concerned about things, we do normally break things. So that's when we involve the red team exercise to break things, to see what the result would also be, and also what is the actual risk rather than a hypothetical risk. So yes, we do, but also do it in a controlled fashion. Controlled fashion is that do not go to your production network and start breaking things. That's where we build the model office. Model office is a replica of production offices. And within a model office, which is like a test lab, you replicate the actual type and make a model of that device in the model office, and then you carry out the TTPs on that, okay? So there isn't any change in dynamics. The only change in dynamics might be volume and velocity. the volume because the production network might be handling 100 terabytes or zettabytes of data, whereas this is limited. But in terms of make a model and spec of that particular technology and the TTPs and the way in which you do the TTPs are identical.
Mm-hmm. I think that you just answered the next question, which is would you recommend as a best option as open source training for this area?
I would recommend the combination, say hybrid. So open source is a good way to start. And then you can then have your 80-20. So those open sources, whether it is Nessus, for example, you're using for your scan on Nmap, or whatever tool, without naming tools is good. But what we also see is if you work in mission critical and CNI space, you do need some customization. So you customize it based on the weakness of the target. So when I said focused testing like the G-best or C-best thing is, we first of all understudy the target. What component, what year was it manufactured, what, like the ICS, Industrial Control State Systems. So you first of all understudy the target system, and then you launch a targeted attack to exploit those weaknesses you've seen just so that you understand how they will fail, whether they will fail open or fail safe. So you understand the actual impact in terms of if the attack were to be successful, what impact would it have, whether it would allow you to steal data or how it would behave. So that's when we'll launch very targeted, focused attack on a target system.
Mm-hmm. Okay, so we have more questions for you. Next one is from Professor Sadie Chris. It says, how should organizations prepare for emerging technologies at the risks that might result just by increasing your attack surface, just because you are using new technologies or because the threats are using technologies that they have much more potence?
Wow, interesting question. I'm probably going to take that away. I'm just going to be thinking out loud here. I don't know the answer. I think my approach would be not because it's a new technology. Let me use one example with quantum computing. The advantage is I can process things quicker. Therefore, if I use example of a crypto system, IES or advanced AES, Advanced Encryption Standard, and we know it's a 256-bit key, how long would it take to break on a conventional modern computer? And we say, okay, it's 100, God knows how many numbers. With quantum, that would minimize that. How long it takes to cryptanalyze that would reduce because of the power of quantum computing. But then it's not the crypto strength is not only on the key size, it's also on how strong is the algorithm, the algorithm that's being used. So it would then to test the resistivity or resistance of that particular algorithm to see if there's any flaws within the system. If it's only how long it takes to discover the key, that's one aspect. But the other aspect is how future-proof is the algorithm. That would be my initial answer. So it wouldn't be because new technologies have come on, therefore we ramp up things. No, it would be nice to have an intelligent testing that would then determine whether we increase the footprint of the particular system, or whether we then question the logic behind the design constraints of the algorithm.
Mm-hmm. Thank you. I think that with that we reach our time limit. But thank you again, Cyril. It's been great. And thank you as well to the other panelists and all the attendees